All right, so in this heating and cooling problem, in our setup of things, we got to the temperature equals A, which is the temperature of like the medium that it's in, minus C e to the negative kt. And if you had a plus C right there, that actually is okay because that'll work itself out when we start putting in initial conditions. But to start the process with this, we're actually going to start with the initial condition. And the initial condition we have is that the temperature of the bar is 350. We know the room temperature, which is like the temperature of the medium, is 70. And if it's the initial condition, the time is 0. And so what happens is we end up with 350 over here. The temperature of the medium is 70. We don't know C, and we don't know K, but it doesn't matter because initially our time is 0. So then this whole thing goes to 1. So then we really just end up with 350 minus, well, here, equals 70 minus C. So then you'd add C to both sides and subtract 350, or you could subtract 70 and then multiply by a negative. But your C ends up being negative 280. So then now our model after that becomes 70. And then this is where I had a minus built into the way I'd set up the equation, but now based on that minus, I ended up with a negative for C. So that minus a negative becomes plus 280 e to the negative kt. So that's where we're at so far. Now the next thing to do is to take this next set of conditions. I know that after 2 minutes, so when time is 2, the temperature is 210. So now I know my temp is 210. That's still 70. Now it's plus 280 because I figured those values out. E to the negative k, and time is 2. And then we're going to now start solving for k. So minus 270 here. Just going to flip around. Negative k times 2 is negative 2k. So we have 140 equals 280 times e to the negative 2k. We divide by 280, which this is just 1/2, equals e to the negative 2k. So the natural log of both sides means that ln of 1/2, whoa, I don't know what's going on there. And so my constant is ln of 1/2 divided by negative 2, which, I mean, you could leave it like that and have it exact, but it ends up being a decimal around 0.34657. So now we have our full-blown model. T equals 70 plus 280 e to the negative 0.34657 t. Sorry, that got real close to where we wrote that other stuff, but. And now I can go answer some questions. So the question I want to answer is, what is the temp after 4 minutes, which is just plugging in 4. In for T. And if you crunch that all out, it ends up being right around, I think almost exactly 140 degrees Fahrenheit, that would be. And then to get the time it takes for the bar to reach 100 degrees, I'm going to take and set my temperature to be 100. I'm going to solve for t. So subtract 70 from both sides leaves me 30. Oh, sorry, I've got a pretty good stylus, but it's not great still at writing as clear as a pen. And I can't put my hand on the iPad because then it messes up and clicks on other things. So I'm doing the best I can. And then we need to divide. I'm going to do this in 2 steps. I'm going to divide by 2, or I'm going to do this in 1 step. I'm going to divide by 280, and I'm going to take the natural log just to save a little bit of writing. So the natural log of that fraction equals negative 0.3467t. And then I just divide. And the natural log here ends up becoming negative because it's a fraction, or it's a decimal between 0 and 1. And then I already had that constant being negative. So it should end up around 6.4 minutes. To get down to 100 degrees. So certainly you can ask questions in class as well. We have a work day tomorrow, but if you were wanting to figure out the rest of that or even just double check your answer, there you go.